In JavaScript, we can process the items in a collection or list in a number of different ways. The examples can be using a for and for each loop, or we can use the map and filter functions. With the introduction of generators sometime back, it has become possible to have a custom behavior of the for loops when it is returning new values in every iteration. It also allows us to have normal objects as iterables in addition to arrays and maps. So this is why before we can learn about generators, it makes more sense to understand iterators and how they work before we can move on to generator functions. An iterator is simply an object which implements the iterator protocols defined in the ECMA 2015 standard. This means that an iterator must return an object having properties done and value. The done property will be Boolean type and will return false if the iterator is still running, otherwise it will return true if it is finished. The value property will return the value after the current iteration has been processed. In this code example, we have an array with a number of different items and we are going to print all of these items into the browser's console. To do that, we can use a for loop like this one over here, and this for loop is iterating over all of the items and then the items are individually being printed to the console one by one. We can create an iterable ourselves which will return a number in a sequence of numbers in every iteration by calling its next function. So for this example, what we can do is we can create a function and let's just call it get addition iterable, and this function is going to accept some arguments. For example, we can get the value of the start value and then we can also get the value of end. Let's have the default values as 0 for start, 10 for end, and then let's also have a number which is going to be added in each iteration to the initial number so that we can have a meaningful series with us. So let's have another variable and let's just call it current, and we are going to set the value with the start. We need to return an object from this get addition iterable function which is going to have the implementation of the next function so that we can use it as an iterable. So let's just have an object and let's call it addition iterable. Let's create the next function. Now in each iteration we need to check if the current value is less than end. If it is bigger than or equals to end, then we need to stop returning new values from this iterable, otherwise we are just going to increment the current value with the value of the add variable which is provided in the arguments. So for that, let's have another variable and let's just call it result, which we are going to use to hold the result object which we are going to return. So if the current value is less than end, then what we need to do is we need to assign the result with a new object and we need to provide the values for the done property, which is going to be false because the iterable is still going to run, and we also need to provide the value which is going to be the value of the current variable, and then we need to increment the current variable with the add value which we have provided in the arguments, and then finally we need to return the result object from this iteration. Now if this condition is not true, it means that the iterable does not need to proceed further, and then we can safely return the object with the done value as true, and we can also provide the value which is the final value which is the current, and then finally we can return this addition iterable object from this function get addition iterable. Now the use of this get addition iterable function is easy. First we need to call it one time so that it will return the iterable object to us, and then we can call this iterable object's next function one by one to keep on fetching the next values in the series which is based on the initial values which will be provided in the arguments. So I'm just going to fetch the iterable object first and let's just call it addition iterator. Now to log all the values which this iterable is going to yield in the browser's console, what we can do is we can simply first call this iterable's next function, and then we can use a while loop to keep on calling the next function again and again until this done properties value becomes true, which will simply mean that this iterable is not going to yield any more values. So let's just call the next function for the first time, and we are going to store the result object into another variable. Next, we can use a while loop and we can check if the done properties value is false, then we can log the value to the console, and then we can also call the next function again to fetch the next value, which is going to be provided by this iterable's iterations. Now when the done properties value will be true, which will mean that the iterable can no longer progress, it will simply mean that the code will not go into this while loop and it will simply exit it. So this is how the values are going to be logged into the browser's console. You can see that the iterations have stopped at the maximum value or the end value which we have provided for this iterable function, which is 20 in this case when we are calling it. So why even use and have generators when we can have iterators? Well, for one, the iterators need a careful implementation of their internal state. With generators, we just need as much as a single for loop. A generator function can be created using the syntax function and then asterisk. It can return values for any iteration using the yield keyword. When generators are called for the first time, then they don't do anything and they only return a new iterable. Now when the iterable's next function is called, then it will keep on returning next values in every iteration until it finishes. For any list of collection which is computationally expensive to generate, we can use an iterable created using a generator function. This can allow us to compute next values only when the next function is called. So now I'm going to show you how we can convert this entire function into a generator function, and then we will not have to deal with this entire code of maintaining the internal state and the closure of this function's scope to create and return an iterable. So I'm just going to copy this line from over here, and then let's just also comment out this entire function so that we can create a new one, a generator function. So first let's just paste the line of code which we copied, and now to create a generator function, all we need to do is first put an asterisk over here after this function keyword. This will indicate that this is a generator function, and now the internal code of a generator function for the same logic is going to be vastly different from what we did for the iterable object. So this is the internal logic of this generator function, which is similar to the above function which we created for the iterable. You can see the noticeable difference between the lines of code and the simplicity of the logic. We are simply first getting the value of the start into another variable which is called as current, and until current is less than the end, we are going to yield the current value or the current variable's value, and then after we have yielded the value, we are going to add the add arguments value into the current, and that's pretty much it to get the same output. And the code which we had written for the iterable object is going to work for the generator function as it is. First calling that generator function is going to return an iterable, and then we can use the iterable in a while loop, and we can also use this iterable in a for loop too. Like this one over here, we can simply use a for loop to log the values of each iteration to the console of the browser. So I'm just going to comment out this while loop so that we can see how it is going to work, and let's also comment out this line of code too. So after reloading the page, you can see that the output is the same. If I were to change the value which is being added to the number of the current iteration, let's just change the value from 2 to 3, and let's now see the output. And now the list is kind of different. The number of values which are being returned are less than previous iterations. We can also provide an argument to the next function of the iterable. This argument can then be used inside the generator function to have it behave differently or to change its internal state. For example, we can change this generator function's logic for it to accept an argument in the next function whenever it will be called, and that argument can be added to the current value which is being returned from the current iteration. To do that, we are simply going to fetch the value which is being passed as an argument in the next function in a variable whose value can be fetched from this yield statement, and then we can go on normally adding the add argument to the current value, and then we can check if this add more value is valid, then we can add it to the current number. So the steps are: first the value will be yielded, and the argument in the next function will be provided in this variable, and then we can use this variable in any way that we want to. Now to test the above code in which we are providing an argument in the next function, I'm going to write a number of next statements and then we are going to directly log them into the console. So in these lines of code you can see that the next function is being called of this addition iterator, but in two of these statements we are also providing an additional value as an argument. Now this value, as we know, is going to be added to the current value which is being returned from the current iteration, and we can actually observe these value changes in the browser's console because all of these values are being logged to the console. Also, based on this end value, our iteration should finish at this statement, but let's see what will happen when we are logging again 2 times after this. So this is the result of our previous code in which we are individually calling the next function of our addition iterable. You can see that in the third step and also in this step we are providing additional values in the next function's argument, which are being added to the current number in this sequence. And so our sequence has ended prematurely, and then for the last 2 next calls you can see that the value is undefined and done is true. So done being true simply means that the iterable is not going to return any more values and it has finished, and as you know, done being false will simply means that the iterable has not finished and it can return more values. And this is how you can create iterables using a generator function in JavaScript. So do you think that generators are a nice addition to JavaScript, or are they there to just complicate things for us? Do let know what you guys think about it using the comments area. Also, if you think you like this video, then please just hit that subscribe button. This will make sure you will stay updated with new content on this channel, which is releasing every now and then. Till we meet in the next video, have a good time.